Live from all around the world, these are the Curious Bunch. From Zurich, Switzerland, Daniel Cvetkov. From Glasgow, Scotland, Kristina Kirova. From Lethbridge, Canada, Vasil Tudorinov. And from all around the world, a bunch of curious people. This is Curious Bunch. Hello, Curious Bunch, and welcome back to our weekly podcast. This week we're gonna talk about photography. Thank you so much for joining us. With me today there is Krisi from Glasgow. Hi,
Hey
Krisi.
guys, good to see you again.
And we have Vasko from Lethbridge, Canada, far away.
Hello!
Ooh, he's loud, probably. So I'll just lower his voice. Maybe we'll get to the tones at some point, but keep up with us. It's just our episode number 9, so what can we do? But we have good lighting this time, because we're doing photography, we were just talking about this, how finally we have good lighting. We have our camera, see, Krisi has prepared his camera, and then Vasco also has like a monitor behind him with some birds. What are these birds? Why are there birds? Who knows?
Ask Chromecast. I also have my camera prepared, and my other camera, and some of my lenses too.
Damn, people were prepared this time. And Vasco's camera seems bigger. Like his two cameras seem bigger. We'll talk
It's
about
not
this.
about the size; it's about the photographer.
Vasco, if you lower your volume a little bit, just as we go
I
on.
will.
I think you have something on my beard, but can't figure it out. Okay, maybe not. Whatever. Okay, so we'll start today with the news of the week, of course, as we do almost every single time since the last 3 times or so. So first we'll start with Krisi and her news of the week. And here we go.
So my new of the week is actually computer related. It's about a huge one of the biggest data breaches ever in the history, and it's coming from Capital One, which is a U.S. Credit company for issuing mainly credit cards. And the fun thing is that the breach is coming not from a hacker, but from a previous employee of Amazon, because apparently Capital One was using Amazon Web Services or the Amazon Cloud, and an ex-employee of Amazon has just published a code in GitHub because she was aware of one of the firewalls that wasn't secure. And she just published the code in Git, and now she's arrested, and 100 million people are affected. Their personal data just leaked. And yeah, now Capital One has made sure that everything is back to secure, but apparently there's going to be consequences yet to be discovered. That's me.
All right, thank you, Krisi. We'll go now to Vasco. Hi, Vasco. It's your news of the week. What is happening?
Hello. It's something very interesting is happening because this is kind of in my field, in gravity. They had some breakthroughs using machine learning algorithms solving the long thing that you see on the title of the article, which is SU8 supergravity with N4 and N8 supersymmetry, which is a big deal because up until now, like these things, the big numbers SO8 represents a symmetry group. For now, don't be scared. symmetry group means, and the number means that, so it's 2 times 8 squared is the dimensions of the manifold. What's the manifold is the space, dimensions of space that our theory lives in is 2 times 8 squared. So it's like a 100-dimensional space. And we have basic rules for this space, but we, using just our brains and just simple computational methods, we cannot apply them very well. We cannot go to 100-dimensional calculations. But what this article is talking about is they were able to use machine learning algorithms with collaboration, I think, with Google, to be able to simulate and solve all this 100 dimensionful spaces, which is a huge deal, and I think it's a very strong leap in theoretical physics in general. Because as far as I know, this is the first time machine learning is applied directly to theoretical physics, and it has like outstanding results. And I'm really stoked to see what will happen in the future with that much power, computing power behind physics.
All right.
Thank
you. Thank you, Vasko. Right. By the way, before we move to my news, which are not really news of the week, I'm just gonna say that I think this thing, like the news that Vasco presented, is just sounds so interesting to me that like I did not even understand the title nor the abstract and the description, and it sounds super interesting. And he sounds so stoked about this thing that I would probably like to make an episode about this at some point in the future. And I just forgot to say, Krisi is monitoring the live chat. So, ask questions whenever you want, and we'll try to answer them. Just now I saw that one of our common visitors, Kalyan Genkov, has shared that that Bulgaria has a breach of their own, which we were thinking about talking, but we decided against talking about it because it's just so complicated, and I don't even want to know like the details, and I've seen like some news there, and I don't want to go into it. So we'll move on into our own news. So the news that I wanted to share is not really news, so it's 3 things. Number one, our friend quantum astronaut Dani has shared a video about quantum computers of his own based on his Patreon wishes, and the Patreon this month was me. And he presented a really, really cool video about how quantum computers work, and basically most of the mathematics behind it, which in our podcast we just briefly skimmed as some kind of mathematics. So it's really cool. Check it out. Really fun. This is hands down the best video that I've seen in description. One caveat though, it's in Bulgarian, so if you don't speak Bulgarian, well, you're gonna learn Bulgarian, mathematics, and quantum mechanics at the same time, so it's an advantage. And this was our podcast that we made about 2 weeks ago now about quantum computers. So if you haven't watched this, watch it as well. Of course, like you have the infinite amount of time, so you can watch everything that we produce and that YouTube produces that we tell you about, so you're gonna watch it. And one more thing about Dani, he created, I don't know if that was by intention or not, he created another video about geometric optics, and we're gonna cover a little bit of it tonight probably. But it's also a really cool video explaining mostly 8th grade physics and again about optics. And it's again in Bulgarian, so if you want to learn some Bulgarian, some optics at the same time, make sure you watch it. And last one, before we continue, I saw this article and it made me think about it just because of the topic that we're going to talk about tonight. It's cool to have cameras, and some people make it as a profession, and there's so much science. It's so fascinating as a hobby, profession for some, but some people turn it into a disrespectful way to, you know, you should enjoy a little bit more the nature and the people who are working in these fields, because in this article they're describing how cameras and photographers pretty much went into the fields and started shooting, all sorts of pictures, posing and destroying the crops, and that's not really cool. And in today's world where we all have like Instagram, Snapchat, and I don't know what, try to be a little bit more respectful toward the nature and the people who are working there. So, not really news, but it's a cool article that actually got put up in the last week, and it's a very, very good read. So, with this caveat, we're gonna move into our real topic of today as soon as I switch the whole view. Hi again, guys. You're back on camera.
Again, we are still here.
Yeah. So, the topic of today.
Dani said, yes, as Dani said, I will monitoring the questions both on Facebook and YouTube. So if you see me watching and not paying attention, I'm still paying attention, but I'm just reading comments. And our one of the first comments was coming from Mirela Nepetova. Hi. And she's saying, Vasko, let's do some machine learning. So, Vasko,
You should learn some machine learning. Learning machine learning.
I am trying. Let me first solve the biggest problem in physics, which is quantum gravity, and then I will learn some machine working.
Yeah, it will take you like 2 years?
This is a regular week for me, solving the most difficult problems in physics ever, and just...
Ay. All right, so... yeah, Krisi, your mic is a little bit low. If you could move it a little bit closer to you. Right. So, as we are getting started, I have this book here, which is Randall Munro's Thing Explainer. This is the guy, by the way, XKCD guy, for the ones that don't know his name. It's a really cool book. What he's trying to do is explain everything in the 1,000 most popular words that are in the English language. And what I saw is one of the articles, which is, you have it right here on the left or the right hand side. You have this thing, which is how a camera works. And I'll put it now on a big screen so that you guys can see it. And I'll put Krisi, because she'll be talking about cameras next. Let me configure all of the things. Boom. Right, and Vasko is down there as well, so he can join the presentation about cameras. But it's a really cool book. Definitely, if you want to take a look, buy it, because it's really nice. It's really funny. It's exactly in the style of XKCD. Really cool dude. So that's what I wanted to show about digital cameras. I know almost nothing else. So, let's start.
Oh, can you put me somewhere when I'm not in the way of the presentation that much?
Yeah, I'll just put you nowhere.
Or you just put me a sound. I can...
Yeah, you will be sound.
Yeah, perfect.
So Krisi will be talking, and make sure you have your mic close to you. So,
okay.
The podcast is yours.
Oh, I'm taking... Yeah, put the only girl on the screen.
It's your topic.
So I wanted to start very briefly from the very beginning, and basically the very first camera, or the prototype we got, and it was centuries ago, and it was called camera obscura, and it's literally a box, and there's a pinhole in it, and if you make the box big enough, you can be inside the box, and you can see through the pin, as it's shown on the picture, what is outside, which is pretty cool. And then they figured, once the photosensitive material, or otherwise known as film, was discovered, was made, more or less, they figured out that they can just shrink the box and put this material inside, and then they can capture the light coming from the outside. As you can see, the image is inverted though, but you can just flip it. So so it's not a big problem. And on the right-hand side of the slide, what I'm showing, this vaguely not very focused picture, is actually a project that I was doing in high school with my astronomy teacher. And it was about build your own camera obscura and record the sunrise. So like the sun every single day when it's rising for maybe 10 or 15 days, and then try to get the picture out of it and then scan it and have it. And it was like the point was to try to measure the angle, and the angle is directly related to where you are on the earth and all of that. But I really like the idea because it shows how simple yet powerful idea it is, and like how our cameras looked back then, a couple of centuries ago. And
So how is what kind of material have you put so that you can record the picture?
sorry, we just put like a old film, old photosensitive material. I remember it was more than 10 years ago, so I don't remember all the details. But it was basically an international project, and they sent us via the post to everyone who was interested. Uh, do it yourself kits. So we got the box that we had to assemble. We got the small piece of uh,
Photosensitive material?
sensitive, yes, not synthetic, photosensitive material. And we just had to make like a super small hole and put it somewhere to record. And you can see how much brighter the sun is in respect to everything else around. It's like basically it's burning the material.
And why is it
And
a
yet,
little
how many
bit
days you
like
need?
white? Is that the physical size of the sun that it's going, or what is happening here?
No, it's white because it's within a couple of days, and the sun is moving. Because the sun is not following the same path every single day. It's not following it's not rising from the very same spot. So you get it over the path of over the duration of a couple of days. You actually get it moving, and you can actually record this path.
Right. So we were talking about this in one of our episodes, the flat Earth. So if the
Yes.
Earth is flat, it's basically rising on the edge, and that was one of our arguments against the flat Earth, because then at every different latitude on the planet, we're gonna have this different angle that you see
Yes,
here.
that's right.
Yeah. All right.
Exactly.
We're moving forward, or Vasco, if you have any questions.
Yes.
I don't have any questions. That was
It was
really
a very
finely
quick.
explained.
All right. So we're
Oh,
moving
thank you,
forward.
guys. It was a very quick explanation, and I guess I just wanted to show what I was doing in high school.
Yeah, that's the beginning of
Just gonna say that what you see on the scheme is a deceptively large hole. The hole needs to be literally a pinhole.
Right.
Like, and you actually can control a little bit of resolution if you can do if you can measure the
If you can
actual
put it up
diameter
and
of the
down,
hole.
if you
Like
can
put
make it larger and smaller, yeah.
Yeah, if you can make it larger and smaller, you can use it to get a better, less blurry picture.
So pinhole meaning that it has to be within the dimensionality of the wavelength, right, or something like that. This from what I remember, the wavelength
If you
of the
get
light.
it,
If it's
no, I don't think
No?
this is
if
right,
you
because if you get it so small, you'll get interference,
Oh yeah.
and
Okay.
for a picture you don't want interference.
Oh yeah. Actually, it's nanometers, right? So it's impossible. Like this is crazy. So
yeah,
something.
it should be small, but not like a nanometer, because of course you get from a single pinhole you won't get only interference, you get diffraction and then interference, and which is scientifically interesting as well because you can measure
Yes,
the
but it's not
wavelengths
what
and
you
stuff.
want.
But
I
yeah.
have a question now that we've spoken about this. I mean, I know we'll move forward, but I just have a quick
We're
question.
like on the first slide.
I know, but it's curious. It's curious bunch. So, is there like a minimum and a maximum size of the pinhole that can be calculated in some way?
Yes,
What would be
there
the way to
is a
calculate
way.
it? I'll
I
put
cannot do
Vasco
it on the
on the
top of
screen
my.
so that
It's
He
not
can
I can't do it from the top of my head, but it's a few wavelengths, like 10 to 100 wavelengths is.
But does it have to be proportional to the wavelength in some way? Or
No, we're just gonna. When we are calculating it, we are going to get it in terms of the wavelength we are looking at. Because that's we want like the interference is because the optical path between the two rays is proportional to proportional with an integer proportion between the two optical paths and the wavelength. So when we calculate where what size of the hole will actually break the coherence between the two rays, the two diffracted rays, we'll get the size of the hole in terms of the wavelength. Did that make sense?
I'm not sure, but it would be an interesting question. I'm sort of getting it, but not really. Okay, shall we?
What is?
Sorry, Krisi, can you say that again?
Oh, sorry. No, I was just wondering about what is the upper limit? Like, yes, you cannot do it very small, but how big you can do it? I guess this depends on your
Just from top
resolution.
of my head, like remember my when I was 8th grade, this was like more than 16 years ago.
What?
No.
16? What?
Well, around 14, 15.
What? Am I that old? Wait. I'm getting a panic attack here.
No, 10.
10. 10 is more
Six-
like it. Come on.
11, like 8th grade, we were quite 16.
Okay, anyway.
Okay,
Yeah.
guys, you're old.
Yeah.
Just accept it.
Yeah,
Whatever,
okay.
we're old. It was a long time ago when I did these calculations, but what I remember, that's my
Yeah.
point, is what I remember just from top of my head is the upper limit is kind of dependent on the distance to the object you need to you want to photograph.
Okay, Krisi, you ready for the next slides?
Yep.
Let's move
Alright.
on.
Moving on. So,
Moving on. So after the pinhole and all of the bulky cameras and stuff, then we move to field cameras, which it's not, yeah, those are not really film cameras. Anyways, so the film cameras for those with you buy a film and you have like 31 or 32 postures, and then you have to go in a dark room and use some chemicals and all of that, which are very bulky and annoying and really, really hard to get the focus right, especially for astronomy observations, for capturing, for example, solar eclipses. I've heard numerous stories about people adjusting the focus, so they were hell. Obviously, they also had some advantages, and funnily enough, some people in professional schools learning about photography professionally, they're still using them. But then maybe 20 years ago, we got our first digital cameras. And on the slide, you can see an example of a digital camera, Nikon. In this case, the most well-known brands are Nikon, Canon. We got Sony, Pentax, Olympus, and smaller brands. And they're called DSLRs, which stands for digital. Sorry, I always
single
forget this.
lens reflex.
Single lens reflex. Yes.
So, what is single lens? I can see more than one lens, so what's up?
I think it refers to the single lens LED. So basically, the
Can I interject?
Go
Single
for it.
lens
yes, please,
means
because
like
I'm not really sure.
like, can you put me on the screen?
I'm putting you on the screen.
Oh, that's gonna be
So
a fun one.
Go for it.
This is a really this is a lens, and this is what we call lens in photography, but it is actually a series of lenses and mirrors and collimators and whatever. So it's a really complex.
Collimators.
Yeah,
What
these
is
are
a
lenses
collimator?
that. These are the lenses that help with focus. Just, I'm not going to go into details because it will be long.
Okay.
So this is actually on the picture that you put in the book. You actually have a slice of the lens, and you can see that this is actually made from many lenses. And it's but the optical instrument as it is in photography, yeah, you see that's made from many different kind of lenses. But the whole instrument in photography we call the lens, and because
Alright.
it uses a single lens for a single camera, is called a single lens.
But
And
which
it
one of
reflects
these
because
lenses is the single one? Because I see 1, 2, 3, 4, whatever.
no,
20.
the thing is the whole
The whole
optical
system.
instrument is
This
called
whole
a
thing.
lens.
Okay.
Yes.
So do we have like double lenses in some way? Like, can we have DDLR, like digital double lens what was it? Refractor? Yeah. Reflex. Okay.
Reflex, yeah. If you have like something like Gatling gun with different lenses that change, maybe it can be called like a multiple lens digital whatever. But
Okay. I
it
guess.
would cool. It will look awesome though. Imagine like a
Yeah.
Gatling gun
Wouldn't it be
camera.
be like our eyes? I mean, if we have like a 3D camera in a way, 3D camera that is
Ooh.
shooting, it's like if these
A 3D
newer,
camera is technically two dual lens because it has two lenses.
right? So this would be like a
It
dual
just blew my
lens.
mind, dude.
Dude, you learn every day something new from me, even though I have no idea about this topic. There you go. All right.
And the reflex part is because when the sensor or the film is not exposed to the light, there is a mirror which reflects the light and goes into the visor.
We will be talking about this soon, I think, but before we move
Yes,
into that,
that's
Krisi is gonna be next with something which she has on her desk. What is that?
yes. This is basically the thing what you get when you remove this mirror that Vasco just mentioned. So it's literally because the DSLRs, got it, they have a mirror. So the moment you press the shutter button, because our topic is what happens when you press the shutter button, so we're getting there. So the moment you press the shutter button on, say, a Canon conventional DSLR camera, the mirror goes it's like that, and the mirrors go like that, and the light passes, and it
So
hits
what
the
we have
film,
here on
and
the
it records.
right, what we
Yes.
have here on the picture, it's something like this mirror, right? The blue thing here
Yes.
is gonna move here somewhere, so it's gonna block, so it's gonna allow
It's
the light to go to the image sensor,
yes.
and and so it will stop you from viewing for a split second what is actually happening. While in the mirrorless, which Krisi has, this is the Sony
Sony
camera.
Alpha 6. Okay.
Yeah, what we have is just this image sensor here without the mirror itself and the penta mirror. Wow, penta, man.
And you
Love
can
mirrors.
see it. It's much smaller. I think I'm not sure if Vasco has his camera, but if you compare it, you have probably seen both.
Yeah,
If you
Vasco, can
compare
you
the
put your camera
DSLRs
as well?
to mirrorless, you can
The
see that
bigger or the
mirrorless
smaller
has
one?
I don't know.
the
Okay,
bigger one
so
for
it's
yeah.
bulkier, right? The body itself, not just
So it's
the.
almost double, yeah. Like we're talking about this bit here, which is like this.
And
We're not
that's
talking
because
about the
of the mirror.
yes, because you remove it and then you
What are
shorten.
the advantages and disadvantages of these?
The advantage is obvious. It's much smaller. It's much more compact. It's much lighter. Um, Also, if you, one of the slight advantages would be that you don't require any power to remove the mirror. However, if you want to have the viewfinder, this one, because you literally don't get any light coming to here, so you basically don't have a viewfinder. So the first mirrorless models didn't have the viewfinder, but then they figured that people love those, so they just did an electronic one. So basically, you know how the screen, you have the picture on the screen, and then you got the picture, the same screen, but like much more. And apparently, this drains battery, so you get to have a really, really good battery in order to have a proper shooting mode.
But you also have a
The
smaller
other,
body, so it's less battery, right?
Yeah.
I think the size of the battery is more or less the same. Like the where it stands is kind of fine. The other disadvantage, which is not that clear, but still, the mirrorless cameras are not that robust and rigid and stable. And sometimes, if you try to put a huge lens on one of those, you can have like the balance of. However, they're building it like the newest models, which are obviously super expensive, but the newest models are much more, the body is constructed with like from better materials, it's waterproof, it's more stable. So definitely I feel like the progress is, like the technology is pushing towards mirrorless cameras. And you can see it even with Canon and Nikon. Canon pushed a lot of their models. Another advantage of the mirrorless is, you can use it with pretty much any type of lens, like front lens, just because this distance is smaller. So if you have a lens which needs a bigger focal distance, you can just add a ring, like an adapter. And you cannot do this with the other cameras because you cannot shrink the body. You can just enlarge it, if that makes sense. So it's really good for um, old lenses, like the very Asian one.
You can do
Um,
this in that with other cameras. You just need additional optics, which is you basically need an additional lens, a small
yeah, but
lens towards
introducing
the adapter
another
to shorter.
lens. Okay, yeah, that's fair enough. But like
I'm not
introducing
saying
another
it's
lens is not a
that
good
has
idea.
have problems. I'm
Okay.
no, I have a old Russian lens
Ooh.
for which I adapted to Nikon, and it works perfectly. With it's just another small lens, basically the same idea as the collimator, to um, compensate for the for the different thicknesses of the body and the different focal distances. So you can do this, but you introduce some defects by introducing
Mhm.
another optical part between the lens and the body.
Yeah, I guess you're losing some percentage of the light, so it's never as perfect as not having anything in between. I guess, I mean, they can figure out ways. That's fair enough. Um, yeah, but
And I can
definitely the
tell you
main
why it
advantage is,
drains battery so much, the visor, because the most of the battery for a DSLR is drained reading the matrix, the chip, when taking photos and recording. So you to have the digital visor, basically it's reading like every second or every tenth of a second. It's reading the visor, the chip, and displaying it on the visor. So that's why it's draining so much battery, as
okay,
opposed
that
to
makes sense. Yeah.
my camera can sit idle for days with no taking pictures, and the battery wouldn't drain at all.
But I think you
It's
guys,
bulky, it's heavy, it's
you both have your points. But I'll say something that most people I think, who are not photographers, have this different kind of camera, which is a phone camera, right? And my question would be, so what's the difference? Why can't I just take pictures with this one? Krisi.
I would say, first of all, the full cameras are actually very small mirrorless cameras. Let's see. Why you Currently we have really good phone cameras. So for some landscapes, for some particular reason, like for some particular setups, phone cameras can be really good. Um, so I'm not like dismissing them. I often use my iPhone to take photos and it's pretty good. Um, they're really bad for very specific cases. For example, having low light, wanting to shoot during the night, long exposure photos, just or very fast, um, like speed motions. For example, if you go on a race and you want to take the perfect shot of the perfect portrait of a running person. Or if you want to use a huge zoom, for example, if you want to take a photo of a bird which is hiding in the trees, you just need a professional camera with a lot of zoom in order not to scare the bird. So, but like for landscapes, for panoramic views, for getting the shot done in the moment, some of the phones have really awesome features. And also they're equipped with very good software usually. So the post-processing of the photo before you see it, like in the moment between taking the photo and seeing it on the display of the phone, there's so much software going on, so much autocorrecting, and some of the times autocorrecting is brilliant. So sometimes your phone is taking 5 pictures and then it's stacking them for you, and the result is brilliant.
So it's more on the software level that
We
the things are being
actually,
corrected.
yes, definitely. Got it.
Also,
Actually, we
they
have a
have
comment
much.
from Koya. Okay, yeah.
Yeah, sure.
Just the comment is a computational photography in smartphones like the Pixel 3, which is the Google one, I think. It's amazing. I would love to see that technology on a more capable hardware DSLR body, for example.
Hey, that's a good idea. Why not having the best of both worlds, like the software and the camera, doing both? Krisi, I cannot hear you at all. I think you completely muted.
Why? No, why? I haven't done anything.
Yeah, that's what my point was going to be, that because we want the phones to be small and you cannot have such
Oh no, say
refined
something. I think
optical
you're fine.
instruments.
Can you hear me now?
Yes.
So we cannot have such refined optical instruments as the DSLR lenses. So and basically the resolution of an image is determined by by the larger of two different resolutions. The resolution coming from the hardware and the optics, and the resolution that you have from the chip itself, like the pixel density and all that kind of stuff. So whichever is larger, that would be the resolution of your image. And the optic the when you have a phone camera, the optical instruments are very limited and are not as
Vasco, is
good.
that the Large Hadron Collider behind you right now?
Yes, it is. Oh no, it's not.
It's
Who
not?
took the picture? No.
It's like a circular buildings.
Ah,
And this
okay,
is the
now I
sky.
see it. But it looked like the Large Hadron Collider. Okay.
I've seen a Large Hadron Collider in one of the loops of
Okay.
pictures in the Chromecast though, which
Oh,
was cool.
pretty cool. All right. So,
By the way, was actually yeah, we have another comment from Koyan that it's not mirror but pentaprism.
okay, because like it's not all of them mirrors, because if they would, then the light can't actually escape. So it's just half-transparent glass in a way, I guess, or something like that.
Oh.
I guess it's like a half-transparent glass that reflects in a way. I don't know.
It can use full internal reflection
Or
to,
yeah, that thing. Yeah.
to reflect still. Just
I
saying, you
guess.
were a physicist once.
Once, I'm not anymore. So excuses,
No, but like,
excuses.
why is it called? Okay, I have a question to Kalyan if he's still watching. Why is it called then pentaprism, not mirror? Why is it not mirror? What's the difference?
It sounds to me like the prism, like the idea of a prism is just glass, and the idea of a mirror is you actually have some coating on the other side of the glass which actually reflects. So the mirror itself like has this silver or whatever material coating behind it, so it actually reflects the light, while the glass doesn't, and only through the total internal reflection you can get a prism or something like that.
They work based on total internal reflection. Yes.
So if Genkuf wants to join the video call, by the way.
Yes. Well, that's why we're called Curious Bunch, because that was the initial idea of the podcast. Not only us just talking, but other people interacting and helping us.
But I'm curious if Genkuf wants to
learning.
join in some way. I can send him the link on the Hangouts and he can join on the video call. That would be pretty cool if he has the desire to do so. All right, shall we move on in the meantime?
Okay. Yes.
Yes.
All right. So what's next, Krisi?
The next thing is the manual mode, or basically this thing. Funnily enough, I'm using my front camera of my phone, which is great. So here in a professional camera, you can change the mode that you are taking a picture of. And manual mode refers to you can basically change everything and you can adjust your photo. And a point that Dani actually made before the show, Dani maybe can talk more about exposure and what it means. Dani?
Yeah? This is not exposure. Which slide do you want?
Go back.
This one? This aperture?
No, go back. Like the exposure, because you are saying that exposure is not like you are saying that exposure is not the same as exposition.
When did I say that?
A couple weeks ago. Anyways, so
We
exposure.
were not on the
Come on, that
podcast.
was that Zachary taught us that. Zachary taught us that the exposure and exposition is a different thing.
I'm pretty sure he didn't say exposure and exposition because he's
Well,
Bulgarian.
it was in
okay.
Bulgarian, that's why, but that's what he meant. It was just as I
Okay,
said,
so-
exposure is the sum of all of it. Exposition is just the time you expose your sensor to light. So basically shutter
So-
speed.
Yes, so like shutter speed is how long you are taking the picture for, or basically how long you're letting the light to be hitting the sensor. Aperture is the basically going back to a couple of slides ago, it's the size of the pinhole, or in modern cameras is the size of the slit in front of the lens. So the bigger you have it, the more light it's entering your film or your photosensitive thing or your chip in modern days. And then the ISO or ISO in Bulgarian. ISO is how sensitive your chip is, how sensitive the material which is counting the photons is.
Sorry that I blanked out for a while, but I was trying to join Genkuf, and he
Yeah, I
just wants
figured it
to
out, sorry.
join by voice, and I'll try, but we'll see how it goes. Right. Do you want to move on?
Yeah.
So gonna remove Vasko now. So I saw this video when I was doing my research, and for the first time ever, it clicked to me like what these F numbers mean. So it's a really cool video. I would definitely recommend it to people who want to see it. But it's really like actually explaining, you know, what's happening. It's just as you increase the amount of light that you want to take, basically the light goes twice or like two times, but that means that the diameter goes by the square root of 2 because of PR squared. And that's why these numbers are like 1, then 1.4, then 2, then 2.8, then whatever the next number, 5.4 or something like that. But it's basically going each step, like when you see F over something, like F over 1, F over 1.4, it's going in this direction. So really cool video, definitely recommend to watch. Krisi, you want to talk something more about aperture?
I wanted to show a picture because like the aperture, it sounds cool. It's a little bit confusing with the numbers indeed, because the bigger the number, the smaller the aperture. So the conventional cameras can go from say 3 point, for example, what I have currently, it can go from 3.5 to 22. And most of the cameras are going to 22. And the biggest number would be 22, but this refers to the smallest aperture. 3.5, it's more important as a number because the lesser you can get it. For example, some lenses has it up until 1.4, 1.2, and the smaller you can get it, the more light you can get. So your picture is they're great for night photography. So like the less the number you have, the better your picture will become. Most of the time, they're great for taking professional looking photo portraits because they get blurred, and you can actually go to the. If Vasco has anything to mention about the physics behind it, more or less.
I have a really cool analogy though.
Go.
It's like you have rain that's uniform and is falling down, and you want to collect the water. You can change two things of your bucket that you're collecting water: how long you leave it out in the rain, which is the shutter speed, and how big is the diameter of the water. Bigger diameter, more water collected. So
And then the issue is the
yeah.
depth of the bucket, I guess.
No.
No?
Issue is actually just you standing there counting the drops and adding a drop for every drop that you see.
That's weird. Why not just the collected water which is in the bucket? Why should I count? I mean, isn't that why I have a bucket?
Well, because that's how it works. It's
I don't understand.
physical the multiplier.
Wait, why is counting different than the amount of buckets I actually have? The amount of water that I have in the bucket.
Because it's usually never a one-to-one correspondence fallen photon one count, because digital means it's a counter. The chip counts photons, so it's 1, 2, 3, 4, 5, 2. Depends on how many bits you have on the chip, your specific chip. Mine is 12-bit chip, so this means counts to 2 to the power 12.
Just
12.
so you know, I'm joining Genkov right now. He's voice only. Hi, Genkov.
Okay, that's
Hey,
Hey.
Hello.
do you hear me?
Yeah, we hear you.
Hi. Great.
You
So
can
do you
mute
agree with the
something
analogy
so you
that-
can hear
Joiner.
yourself.
That Vasco said, or you didn't hear?
I hope you.
Yeah, it's internet. I think. No.
Can you repeat?
So did you agree with the analogy that Vasco said with the bucket?
I was connecting to you, so I didn't hear, didn't listen to him. What's the analogy?
So he said it's like a bucket of water, like all of the exposure is like a bucket of water and you have like
No,
raindrops.
there is a rain and you want to collect some of the rain. The raindrops are your photons. And
Okay.
when you want to collect some of the rain, you have a bucket. And the aperture is how big is your bucket. And the shutter speed is for how long you leave it out in the rain to collect water.
Yeah, that sounds good.
But then I asked if the ISO is the depth of the
Yeah,
bucket in his,
yeah, that's my question as well.
and he said no, it's actually
What is the
counting the
ISO?
amount of drops.
Yeah, maybe. Actually, yes. It's multiplying the water. Let's
Yeah,
say.
it's like for let's say what the light sensor is trying to do is count all the photons and record the number in a pixel, and then you read at the pixel and get the number. And by reproducing the number like a spreadsheet, you get the picture. Well, the ISO is how much do you count for each photon? If it's one, you count one count for each photon. If it's like 100 is 100. It's a multiplier, so it's not just if it's 100, it's 100 times. But yeah, that means you higher the ISO. For one photon, I will record like 3 or 4 or 5 or 15 or whatever.
And this is, as far as I got it, this is related to because at some point you decide to drop this bucket off, and or at some point the bucket is like your photosensitivity is related to how shallow or deep the bucket is. And at some point, if it's like overdrawing, or like if you got too many, if you count in every drop to be much bigger than it is. So if you have set the ISO to be very high, and then you gonna overflow the bucket very quickly, and then your whole photo will be just very, very bright because it will be just over water.
Imagine it like a counter. You have a bit like in a computer. You have a bit that can count from 0 to 2 to the 12 minus 1.
That's a lot, but okay.
So that's the usual. That's my DSLR has that much.
Okay.
So the photons fall and you multiply each photon and it goes into a counter. So if you get the very high ISO and you get many photons falling inside, you're gonna overflow the bucket. When you overflow the bucket, this will affect the pixels around and it will spill over, also, which is not the case with the CMOS cameras, but with the CCD cameras, if one pixel spills, it's basically the whole row of pixels is ruined.
Okay. So it's like, okay, the physical analogy, I think, like the physics analogy of the bucket, I think breaks down when you talk about the ISO, right?
It's not that bad. That actually is a very good analogy for me.
Okay.
It's the deepness of the bucket is how big is the bit of
Okay.
of
But then
that's-
my problem with the analogy is that I feel like the drop itself has to multiply. Like that's what you're actually increasing. Like
Maybe we should talk about film cameras. They also have different films with different sensitivities, and you need a film with higher sensitivity if you want to shoot inside, because there is not enough light, and you really don't want to make 1 second exposures to get the picture because everything will be blurred. But if you use the same film outside, it will overexpose really quickly, and you couldn't make such a short exposure to compensate for it.
right, because
So this thing went from analog cameras to digital cameras. It's basically the same. You have, but in the digital camera you can adjust the sensitivity right away. You don't switch the sensor to change the sensitivity. But in film cameras you need to change the film, and you need to be aware what film are you using, so to know what other settings should you use.
Right, because the digital ISO actually corresponds to some kind of standard, which is coming from the analog cameras, which actually had some kind of material which is different. Yeah.
Yeah.
All
Yeah.
right. We also have Mirela, which is also a photography expert. So it's all of us watching these. Only me, I don't understand anything that we're all like
I
trying to
don't
get
claim
what
to
we're
be an
talking.
expert.
Yeah, I'm just having
Everyone.
troubles with the analogies as well. But anyway, shall we move to the
Well, when you
next?
think about it, everyone knows a little bit like bits and pieces about photography,
Right.
especially people who are astronomers.
Yeah,
So it makes sense
we're all
to have
kind
this
of.
discussion.
So, Chris, you want to be the expert now and talk about your next picture?
Up until somebody
Interrupts you and tells you, but yeah,
interrupts it.
I'll put it on full screen and you still have the voice.
Okay,
So go.
just quickly. Okay, awesome. So currently you can see two pictures and they've been taken one after another, but with different settings. Actually, over the week, I was posting in Facebook some kind of challenges with different photos and different settings. If you can guys notice and just give us comments about if you know how this picture is taken and all that. So here you can see, because we talked about aperture before that, and here you can see one of the applications of the aperture setting, or so-called aperture priority setting. Um, I don't know what. Sorry, I
Yeah,
don't
we
know.
still hear you. What's happening?
Okay. So the picture on the left, you can see how the tower. This is my university, by the way. Promote. You can see how the tower of the university is blurred, but um, the flower, which is in front, is very, very sharp. And on the picture on the right, you can both see the tower and the flower visibly into focus. And I have put on also the aperture the settings, and you can see that the main difference in the settings that I was using was the aperture. So once you make the aperture very wide, very like a small number, which makes a very like big size, and you let a lot of light in, you get only the closest details on very sharp focus, but you get everything else blurred. And that's how professional photographers are making good portraits, because this is a great way to distinguish between the person at front and all the background and get it blurred and nice.
But you can
Currently,
also
you have,
see that the
yeah.
speed is different, right? So you have to do it with a slower speed.
Yes, because this, if you do it with the same speed, if you do 1 second with a lot of, because the speed is again related to how much light you are recording. Think about again for the bucket if you want to. So if you have bigger bucket, which corresponds to 3.5 aperture size, if you have a bigger bucket, you just don't let it stay for that long. Otherwise, you'll get um, a very pre-exposed photo, very light photo. So you need to compensate one or the others. And depending on the situation, you decide which one you want to use, which one you want to prioritize.
Now, the thing that confused me about this is like I can't figure out why this is actually happening, like from the thin lenses that we've studied in high school. Like, why, if you have a large aperture, things are blurred, and if you have small aperture, I mean, I'm talking about the small and big, as in like the amount of light that gets in, not the number. The number is obviously the opposite.
Mhm.
But if you have a large opening, why do you have blurred background? I cannot figure it out. Anybody wants to
Basically,
jump
it's
in?
because it breaks in all that we used in high school that we did in geometric optics. It uses one approximation, and that's the small angles approximation, which means that the first the lens is very, very thin,
Mm-hmm.
and second, the mm, actual rays that form the image are very, very close to the central optical axis, which is
Yeah, yeah.
yeah, determined by the lens. It's the central optical axis.
Mm-hmm.
If you increase that, actually the way the light is bent by the lenses changes a little bit. So the actual focal plane is not a plane anymore. It's like a thick barrier. So when you wait,
Mm.
did that make sense?
Can I tune in?
Go.
Yes. Yes.
Okay, I
Please.
will send a link of a pic. Maybe it would be an analogy actually.
Okay.
I'm sending a link in the chat in YouTube. This is basically the picture of how do you have a focal point and basically 8th grade stuff. But imagine the lens was smaller or bigger, and at the focal point when the two rays meet, there is an angle. And if you have a smaller angle and smaller lens, then if you move forward to the lens or backwards to the lens around the focal point, the image will be blurred less than with a bigger lens. Does that make sense? Can you
Where did you send the
actually
image?
open the
Yeah, because I
on
don't.
the YouTube chat?
I don't see there.
I will send it in the internal
Okay,
chat also.
that's good. All right.
Did
let
you see
me
that?
Try. Yeah. So.
Yeah, and I will repeat.
Okay.
Yeah,
We're
so
there now.
you see at the focal point,
Mm-hmm.
the two of the rays meet at certain angle.
Yeah.
And if you have a smaller lens, which is not with a smaller diameter,
Like the diameter, the D here. So it's thinner.
no, not D. D is the thickness, but
Uh-huh.
the diameter of the lens, like the height.
Right. Okay. So this thing. Uh-huh.
If it was smaller, that
Yeah.
would basically mean that you have smaller numerical
Angle.
aperture at the focal, yeah, smaller angle.
Uh-huh.
And so if you move around the focal point
You get
towards
blurred
the
very
lens or
quickly, right?
in the other direction, it
Yeah.
will not blur as quickly as here. Yeah, exactly. And if you have a bigger lens, it will you will have a bigger angle, and the image will become blurred quicker.
But they will meet at the same focal point, right?
Yes, the focal point remains the same. And basically, when you have an aperture, you have some ring that can change its diameter, and it can reject some of the rays that are coming at higher angles.
But basically, like what I understand is that if you have like blurry, that means that some rays are focusing here and some rays are focusing here.
Yeah,
Like a
basically,
little bit before and after the focal point.
exactly. You can't distinguish because, like Vasco said, two things are defining your resolution: the optical part of the camera and the sensor itself. So if it's a little bit blurry, but not blurry enough so that it goes out of the size of the pixel, you will still think that it's on focus.
Mm-hmm.
Does that
Okay,
make
yeah.
sense?
Yeah. Okay.
Yeah.
So it's like your eyes kind of lie to you that it's still on focus even though it's not.
Like if you have the picture and then you zoom in, then you may see it's blurred a little bit, I would say.
Yeah, but you can't zoom, or you could zoom and then it would look blurred. But
No, I mean like
if
digitally zooming.
yeah, if you have a really high aperture and a really tiny hole, lots of the rays will be really almost parallel. So the distance that looks like in focus is much larger. This is called depth of field.
Mhm.
I remember.
Oh, that's depth of field that we're
Yes.
Yeah,
me and
this
Dani
is
were
that's
depth of
exactly
trying
field.
what
to
I'm
figure
trying
out.
to understand.
Yeah. No, that definitely makes sense because the way you, when I, for example, the photo, if you're going back to the photos, I would manually put the focus. I would focus in such way that the flower would be on focus. But then everything around it would be all of the other rays. And if I have like if I have the smaller lens, that means that a lot of the other rays, because of the small angles, are still close to be perceivable as focus, as opposed to with the bigger lens, they're just way too off. So everything around is just really, 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 really off focus.
Have to see it
Dani
like
looks like he's not convinced.
I'm just can't, I
No.
can't imagine it exactly. Probably like if there is this website where you can play with lens. I tried searching for something like that,
Can
but I
you
couldn't
Let's
find it.
open
let's say it
again?
like this. If you have a perfect lens, ideal lens,
Yeah,
every image that it forms
is
will
on.
be uh, infinitely sharp. No,
Yeah.
no matter where it is, if you have a perfect lens that works perfectly, infinitely thin, and blah 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 blah. So what you see, the two green lines, it's not gonna be like a depth of field. It's gonna be just like one plane,
Yeah.
where everything is
Mhm.
perfectly focused.
Mm-hmm.
Uh, so everything will be perfectly focused. The closer are we to the ideal lens, the better our approximation of the
Okay.
physical lens is to that lens.
Yeah.
By shrinking the aperture,
Uh-huh.
you're getting closer and closer to the small angle approximation.
Gotcha.
So
Okay.
more and more of the things
That's a good
look
one.
better in focus.
All right. Yeah. Yeah. That's good. Yeah. Because then when you expand the aperture, you're actually seeing the physics. Nice. Okay. Whew. I'm glad I'm talking with you guys. That was good. Thanks.
We should rename
Glad to
this
get you
series.
excited.
Explain this to Dani.
This should be the name of the show. Dani trying to understand stuff. All right. What is next on our?
Okay, what is next?
Yeah.
Another advantage slash disadvantage, whatever you want to say it as, of the aperture size is the fact that sometimes you actually get image, not the thing that you want to take the image of, but a multiple copies of the form of the aperture. And for example, in this case, you can see that the picture on the left was taken with aperture priority, and it was taken with the closest aperture size one get. And notice the lamp, and notice all the numerous spikes appearing to come from the light, from the lamp. This light is not really, it doesn't appear as so. It's just a projection of the aperture in some and somebody else can like elaborate on that.
Okay, I've
But
heard this
for
thing, but I
yeah,
don't know how much of a myth it is. Like I've heard that this is where the chip itself is held or something like the points at which it's attached physically to the rest of
I
the
think
camera body.
It's
this is
not that.
definitely the case for telescopes. So this is definitely the case for the definite force spikes you get in a telescope,
Okay.
which is a reflector. But in the camera, I think it's yeah, somebody mentioned
Genk says it's not. So what
it's
is this?
In
different.
the
Yes.
camera, it's because of the aperture. Do we have a picture of an aperture in the slides?
Of aperture?
It's yeah.
I think in the beginning.
No, the
I
thing that
mean,
actually closes
yeah.
the.
Oh,
I'm
It's
thinking
the
made
what
about
of
is it
my.
called?
I can show it. No, I can show it on my camera.
Show it
yeah.
on your
Danny
It's
camera.
made.
Wait.
It's
needs to
made of
show it.
blades actually. Which oh yeah,
I
okay.
can try to.
Okay.
The problem is that I'm not sure if I can
I
focus
don't
on
think you'll be
my.
able to, right? I mean,
Yeah. Maybe a
I
picture
on
would
my
be
Russian
better.
lens is better. Let me get it, and I will
Get
show
your
you.
Russian lens.
Or you could get the whiteboard. It's my favorite
Yeah.
moment when Vasco
No.
Yeah, Vasko, you
gets
can
his
get your
whiteboard.
whiteboard, but I think he's outside with outside.
Oh,
So when the aperture is closed, actually it's not circular, but it's like a polygon, a regular polygon. Is it how
I
it's
can
called
see it
in
with my
English?
camera.
Sorry, I got Vasko twice. I can't figure out who is not on the camera yet. Sorry.
I'm not on the camera.
There
I'm
you
not
go.
on the
You are
camera.
now. Okay, Vasko, you got the Russian thing? Or? Okay.
I'm back.
In,
Hello,
in
hello.
Soviet Russia,
I think the problem is
Camera
my
sees
apertures
you.
are
No,
bigger.
you see the camera. I don't know. Which would be the
the
reverse?
problem is my
Ooh,
Can you
Vasko.
see it
great.
now?
Vasko
Okay,
is
so
big
now.
screen. Yeah, I'll just
In
put him.
Soviet Russia,
Okay.
Go
camera
for it.
sees you.
Yeah.
Go for Russian lenses.
Just
They're awesome.
yes, that's good. Ooh, nice. Okay, so what up again?
So
Ooh,
yeah.
pretty.
So do you see that when he closes the aperture, you see that it's not no longer circular, but it's like a pentagon, I guess?
Right. Close it again. Yeah. You're zooming into your pores of your head, but it's good.
Oh,
Yeah,
now, yeah.
I see. Yeah.
Now actually it's a hexagon here.
Yeah.
So
Yeah.
he has
Mine
six
is
blades, and because the opening is not circular, that makes some diffraction patterns that are correlated to the directions of the sides of the polygon. And the funny thing is that in modern lenses, they usually use an odd number of blades, 5 or 7, so that you have more rays on the star. Because if you have a
Oh,
hexagon, you would get only 6 stars. But if you have 5, you will get something like 10. Because you get all. I don't hear Dani.
So Chris, how many stars do you have? 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? So
Yeah,
that
so
mean
she
like
has 7 blades. 7 blades in the.
wait, so you get 2 per?
Well, we get
Yeah.
a cross line for each one. So if you
Yeah.
count around, you need to divide by 2.
I think the
okay, I
show
can.
again needs to turn into explain this to Dani. What?
I'm trying to count how many. I don't know. Anyway, so that's one of the applications, um, and on the okay, okay, Dani's
I'm into this. Wait, so I get
okay.
I get like a ray here, a ray here, ray here, ray here, ray here, and ray here, right?
And you also get all the perpendicular rays. Or no, actually, no. Sorry, you have. Okay, it could be easier if you just draw 3 blades.
Okay, so a triangle.
Yeah. So from each side, let's say, you just make the perpendicular
Aha.
ray, but they cross, so it makes a 6.
I can't annotate this way, but I think yeah, I think I got
No,
what
so
you mean.
yeah.
Maybe I can do it with this one as well,
From the center of each line,
like this way.
make the
I'm trying something like this.
Oh, what are you doing?
This is how they cross, you mean? Is that where you get the
No.
diffraction from? No.
No, the perpendiculars,
So, okay.
Dani. The perpendiculars to the blades.
Yeah. Okay, just draw a triangle.
I'll
It
draw a
has
triangle.
odd number
I'll
of
start with
sides.
the triangle. Wait, I first need a white screen, somewhere I can draw on.
Oh yeah. So let's Vasco do the stuff. He has his whiteboards.
Oh yeah,
So
he has a
we have-
whiteboard. Do the whiteboard. Yeah, okay.
And
So
now
we draw the
build all the
perpendiculars.
perpendiculars. Yeah.
Yeah?
and now you see that there are actually 6 rays in the star.
1, 2, 3, 4, 5, 6.
Because it has 2 sides.
Ah. This is so okay. So I'm continuing with my questions. Then. Why is the light creating this kind of rays and not the ones that I drew? Not that I can imagine it, but
Because that's how diffraction works.
that's how light works. Great. I don't
Well,
understand how
because
light works.
because let's say you have a barrier
Ooh.
here, light coming here, it's reflected in that direction. So if you extend this to be longer, the light is not going like deflected in that direction, only in where the barrier is.
Where the edge is?
Yes.
Yeah, where the edge is. It's parallel to the it's bending in a plane perpendicular to the edge. That's why it's not happening in that direction, the diffraction. But it's not.
Wait, so in a triangular, so what you drew there, right? In a triangular kind of aperture, right?
Yes.
Light is coming from within the board, outside of the, like perpendicular to the board, basically.
Yes.
Yeah.
Yes, it's coming like this.
Yeah. Okay. So what is light doing? I'm not
It's
sure. I see it.
being
So it's
diffracted from
on the
each
edge
of the
here
sides,
is
each of the
diffracting.
edges.
And
So
it's
the way that you drew it down, like with the waves.
Yeah,
Yeah.
let's
say it like this.
And the trick is that when you have an odd number of sides, you get twice the number of star rays. I don't know how to call it.
Okay.
Rays.
And if it was a hexagon, the pattern would be the same.
But if you have a square, what happens?
For 4 rays.
Okay. So if you have a square, you have 4, but if you have a triangle, you have 6.
Yeah. Because 2 of the sides produce the same pattern and they overlap and you can't
Cancel each
distinguish
other?
them. They
Oh, you
don't
can
can-
distinguish
they don't
them.
cancel in,
They
yeah,
don't.
They just.
do the same.
Mm-hmm.
So
They
that's
stack
why
on top of each other.
newer lenses have an odd number of blades so that you have more stars.
Do people like stars in general? Is that why?
Apparently, yeah.
Yeah.
Wait, Mariela said that you can have a heart. How can you have a heart?
Yes.
You can
Well,
Well, technically, every
in
alive
front of
person
your
has a heart.
I don't understand how one can have a heart.
Dani doesn't.
literally in front of, if you want to be boho, if you want to be Instagram fancy star, whatever, you can just put a small opening. You can like cut your own shape and put it, and then everything would appear in the shape.
By the way,
Like
one
in
thing.
the solar eclipse.
I'm starting to understand because I'm reading the chat now. Mario said that we don't read the chat. I do read the chat, but links
You do read it.
don't appear for some reason. I guess it's like an anti-spam feature of YouTube or something. That's why things.
Yes, there was a message. Yeah.
Because
There
Genkfos
was
said
a
that he sent the
message,
link, but we didn't get it. So probably links in general can be gotten in the chat. So we read it though. But now I remember about the thing with like eclipses, right? If you have like that's one of the ways that you can observe an eclipse. Like if you have from the trees, I remember that during an eclipse, like usually the shadows are just like some small circles, like between the tree leaves. I don't know if you guys know what I'm talking about.
But that's more camera obscura because then you reproduce the image of the sun, not the image of the aperture. And it happens
Right,
because the
'cause it's
rays
just
are
small
actually
dots.
parallel.
Yes.
Okay. But I don't
And
know
the
how
reason you
Mirella.
don't see this, you don't see this happening with the aperture on the lenses is because basically it's the aperture is put on a place where like more like a focal plane or something. N- If you put like uh, make a black filter and just cut a shape in it, and then I point it at the sun and focus not on infinity but at the closest that I can, I will see the replication of that aperture. So I will have the heart that Mirella wants so badly.
Mirella said,
I
yeah,
know,
just
I'm
Google
Googling.
bokeh.
Ooh,
Yes,
so that's
that
what
it
you do?
is. Yes,
Okay.
make a black filter. Just cut a
And
shape
put
in
it
it,
in the front.
put it on the front, and focus on something really close with a very open aperture, and every light that you have on that frame will have the shape of a heart.
Shape of my heart. Like this, for example.
Yeah, that's how it's made.
Sweet. Okay. Thanks, Miro. And Vasko for explaining that, and Genko to explaining that, and me almost understanding.
Thank you for understanding that.
I'm trying. All right. What is the next thing that I have to understand? Oh no, the next thing is actually something that I wanted to show, right? So well,
Go
at
for
least there's these guys who make slow-mo videos. Wait, no, not F5. F5 refreshes the page anyway. So these guys, I think everybody knows the slow-mo guys, but they have like a video about shutter speed, and it's really cool. It's like these two, like in a digital camera, they take like a recording of how when you press the button at different shutter speeds, like what actually happens, and you see how like you have two plates, one is which is falling from above and one which is going from below, and then you can see this small window here, and that's why sometimes you can see this kind of moving left to right kind of image, right? Like when you have a small shutter and you're moving, let's say, in a train, and then you take a picture and you can see, some trees are going, kind of, in that direction or whatever. Like they become diagonal. Is that the reason? Did I understand it right?
I'm not sure I've seen diagonal trees, but maybe if you show.
Like you're moving in a train, right? And you take a picture of like while you're moving, you snap it, and the tree is like standing vertical. But because the way that this is moving, and it's like going from above to below. Like imagine this window basically on the video. Like if I can try to play it.
Oh, the cool effects with the propeller that it looks like wonky. Yeah, that's true. That's how.
So see on this video, I don't know if you guys see it, but this is how it's moving, right? The presentation goes back and forth instead of taking the control of YouTube. It's just. So basically, as this is going up and down, right, the shutter, it's these pixels here are lighted first, then these pixels here, then the pixel below them, and the pixel below them. Which means that if you're moving with a train, the part of the tree will be above, and then the part of the tree will be slightly to the left and slightly to the right, since the train is moving itself. You know what I'm talking about?
Yes, but that happens when you do a video, because they want really quickly to read off pixels, so they put for less pixels, they light less pixels, so the shutter is moving, like for every frame is moving down. For taking a still photo, it's just you have the mirror flaps up for a time, flaps down. That's it.
No, that's not the mirror. The mirror is already up and down. Like I can show you the.
But with this camera, they're recording video.
No, they're not.
recording.
It's single picture with a different shutter speed. This guy is just too much on screen. Okay, now look. Ah,
As we are.
it's just annoying. Okay, look now. At some point, the mirror goes up, right? That's the mirror going up. And now, first this panel will fall down, exposing the lens, exposing the matrix, or whatever you call it, the CMOS detector, thanks Mario. And then the top layer goes down, and then then the mirror goes down again. Do you know what I'm talking about?
Yeah, that's a single frame.
Yes.
But when you're doing, but when you're doing a video, they're gonna go together, like.
Yes,
Or
exactly,
actually
exactly. And
when you
that's
have,
Mhm.
or when you have a really high shutter speed.
Like this is a very
Yeah.
high shutter speed, right?
Yes.
This exact moment, yeah. So this is what's gonna happen, like in a very high shutter speed, right? In just a single
This is
in
called the rolling shutter effect.
rolling shutter. Thank you. Okay.
Rolling
And
shutter and
do you know what the other bad thing about rolling shutter is?
Okay, maybe.
That
Yeah,
it's
go.
really hard to use flash white when you take a picture with rolling shutter,
Why?
because it's actually flash in a really brief moment. So when you trigger the flash, it flashes on, and only part of the image is actually affected by the white. If you have a really short shutter speed. For example, if you have 1,000th of a second of shutter speed and the duration of the white pulse is like, I don't know, 1/10,000th of a second, then you can have only 1/10 of the image illuminated by the flash. And if you want all of your picture to be whited, the flash actually needs to shine several times in perfect sync
Ah,
with the shutter.
that's why you sometimes see this thing bling 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 bling.
This
Or
is for red eye reduction.
Okay, I want to try.
what are you doing? Like low shutters?
Oh yeah, it's flashing. You're right. It's flashing a multiple amount of time.
Yes,
Ah, okay,
and
okay, okay.
it forces your zenith
Okay, I'm gonna do it on
Pupil.
a smaller
pupils to
TV
shrink,
so I
and
can see if
then
it's yeah. Like the light is doing flash, 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 flash.
that's not for the shutter. That's for the red eye reduction.
yeah, this is for the actually
Anyways,
for
it's
the
pretty good.
shutter. It needs to be in the kilohertz range, and you can't see it. But I have tried it, and it's bad.
Like, but if you have
You
like a
need
slow-mo
special.
camera or something,
I don't have one, so I don't
like
know what
slow-mo.
happens. Yeah, but yeah, the flash is really brief, and you need to make some dark magic. So if you want to have flash and short shutter speeds, shutter duration.
Or you just can buy really nice projectors, and there you
Yes,
go.
yes.
And carry it around.
So Marielle says that if it's a CMOS detector, it's all red at once. But we don't have. Do we have CMOS now, or do we have CCDs? I had research about
We have
CMOS
CMOS
are
most of-
usually
I have actually the last produced DSLR model
Uh-huh.
with the CCD sensor in my hands right now.
Oh,
This is
wow.
the Nikon D3000. This has the CCD sensor, and after that they stopped putting CCD sensors in DSLRs at all.
So why? What is the difference?
High power consumption, uh, images are larger, and yeah, basically that's it. The high power consumption. So in this thing with the full battery, I have around 100, maybe 150 exposures before the battery runs out. So which is super bad. Um, with my other is more like I don't know, 700 to 800 before my battery runs out.
I need to say something because I just noticed the time and we're an hour and a half in. Chris, you can interrupt as well. Like you don't need to see.
We can
Just-
continue
just
this
my-
next week.
I think we
It's
should
awesome.
continue this next week. Yeah, like because we had like a whole topic on astrophotography, but if we have to go into it, we'll just go into 3
Can you
hours.
just show the quickly the pictures of the shutter speed that I prepared just to know that we've been through those slides, so we can start from astrophotography next time.
Which ones?
Yes,
This-
those. Well,
this one?
yeah, those
The previous one as well.
Yep.
Mm-hmm.
So this was my personal. By the way,
I
doing
don't.
tonight in the presentation are personal. So I mean, obviously there are so much better examples out there, but we just wanted to make our to be fine with copyrights. So for example, this is how the shutter speed can affect your picture. If you want a blurry background, you go for example 1/80 seconds. Like if you're basically the photo is taken from a moving train. So in this case, on the left picture, you get everything which is moving blurred. If you want it sharper, you have to reduce the shutter speed. So you have to make it much quicker. However, this will result as either big ISO or bigger aperture or maybe both. But shutter speed is great for if you're, as I mentioned before, if you're shooting on like a football or some running competition. If you want to get some things moving very quickly, you just get it sharp.
You're moving your microphone a little bit, so don't.
Sorry,
Okay.
I'm holding it, so it should be fine.
Okay. Next.
The example with the water is very nice to demonstrate how you can stop things or make it like flow.
Yes.
With the
So the
shutter
example
speed.
with the example with the water, it was actually me and Dani when we were photo shooting. He was sleeping back then on the grass, so bad Dani.
Yeah, I was taking a
but,
rest. You were playing with your camera.
yeah, fair enough. So yeah, on the picture on the left, you can. This is like the normal conventional automatic picture that your camera would take. It's basically what your eyes see. The picture on the right, however, it's what you do if you increase the speed a little bit, so you can actually capture the flow of water. So you get not a single. So basically, you're making it less sharper on purpose. You're making it blurred on purpose, just because this looks more magical. It looks more like a flowy thingy. So it's another effect that you can get use of with a professional camera and not very often with smartphone camera, for example.
You can do this with just your phone, right?
I think some of the phones
Switch to
have
night
some
mode and you can.
options. Yeah, but the night mode will probably the software will probably detect it as very. I'm not sure if it's gonna work. I think there's different
my phone it
apps
works,
to
I don't know.
control.
But
Some
I
guys
highly
take-
encourage anyone who wants to do find a waterfall and just experiment with shutter speed, and you're gonna see how at higher shutter speed you're gonna freeze the water, so you see the individual drops and stuff, and at lower well you see the flow and it will look awesome.
Some guys take this to the extreme and put a dark filter in front of the camera, so they could make for tens of minutes flowing water,
Sorry, what can they make?
and it's even more magical.
But
What can
what?
they make? We couldn't hear you.
More minutes.
They put a dark filter in front of the lens,
Uh huh.
Mm-hmm.
and then they can take a picture for tens of minutes.
So they reduce
And
the amount of light that is getting in so that it becomes like a
yes,
really
yes,
long
because
exposure.
otherwise it would be overexposure.
Right.
I've
And
made a similar
looks
thing,
even
very
more
very
magical.
cool. I was sitting at the dock, and I have a natural density filter like with the darkers, and took like a second exposure on the docks. You need a tripod for that, by the way, but it was super cool because you could see the bolts are like the planks that you walk on are super sharp and nice, but the bolts you walk on are like the bolts are blurry because of the waves.
Hmm.
Also, you can do this with like people walking on the street and make like
Yeah, that's
blurry
one of the
people.
pictures that I uploaded in Facebook. It was basically people as ghosts. Because if you're taking, yeah, like you don't get the precise photo of the picture, you just get like a shadow, which is there, which is pretty awesome.
So see, you have to stay until the end of our podcast in order to learn the secrets of what we are posting on Facebook. So stay until the
And
end.
stay
Yes.
tuned because at 12th of August, it's the Perseid meteor shower. So if you,
Oh
we
yeah.
are going to give tips and tricks on how to
We are?
photograph them.
Okay.
Yeah,
For
we are
yeah,
going to give
first
tips
tip.
and tricks.
For first tip, don't stay in Glasgow.
Yeah, you need some clear sky.
And
No way.
so if you want to go out and just take pictures of some astronomy cool shit, just stay tuned.
All right. And next
And we
time
have
we'll be
plenty of other photos to show. Yes.
yeah and talk about ISO and these kind of things, but we're gonna leave it for next time because this otherwise, and we're gonna talk about astrophotography next time because we have like a lot more things that we wanted to show, but we're gonna cut it until here this time. Are you guys okay with this?
Yes, I think it's already.
All right. Thanks very much for watching us. Tune in definitely next time to learn more. It's going to be next Thursday at the regular time at 6 p.m. Universal Time. And see you there. Stay a curious bunch. Like, subscribe, share, and ask questions.
Yeah, thank you
And
guys for
follow me on
watching,
Instagram.
participating,
Oh
and
yeah,
as
two things, right? Because like they wanted to show this thing. Like both Krisi and Vasko have an Instagram, so click. I don't know what you click. You follow people there or something. I don't know what you do there.
yes, I think you for my Instagram is astrophysics related. I think Dani already showed it once, although I'm not really active. I'm not really posting there.
Oh,
Well,
she's posting every once in a while. And Vasco, what are your pictures about? What are your
Oh,
Insta
I'm
snaps?
mostly like landscape photography, but I'm trying to get a little bit into portrait and stuff. So that's what I'm interested in. Also astrophotography, but up until now I lived in a big city with lots of air pollution and light pollution. So
So that doesn't work. But yeah,
yeah.
follow them, click like, subscribe. Do you have bell buttons there? I don't know. But in YouTube, definitely have a bell button. So click the bell button, click the like page on a retweet stuff on wherever you retweet things and etc. So stay tuned until next time.
Bye. Stay
Bye.
bye.
curious.
Have a good week.